Hey guys, welcome to another video. This is Shrikant and today we'll be discussing this problem, binary tree vertical order traversal. Okay, let's jump to the problem statement. So we are given a binary tree. We have to return the vertical order traversal of its node values. Okay, and what does vertical order mean? So let's say we have this binary tree with all these nodes. So vertical order traversal means we have to traverse this and then this and then this this and this. So we have to return the values such that so let's say this is distance 0, this is distance -1, this is distance -2, this is 1, this is 2. So we have to return 9 and 7. Okay, so which are at distance -2, right? Then we have to return 5 6 which are at distance -1, and then 0 which is 0 to 4, and then 1 1 2 3 8, and then 2 which is 8 and 6. Okay, few conditions to note here is that the nodes which are at level earlier should be before the nodes which are at later level. So 9 should be printed before 7. Okay, and so similarly we can see here that in this level number 1 1 3 2 and 8 are there, so we should print 1 3 2 8. But also notice that when they are at the same level, we have to print it in sorted order, that is these two should be sorted. Okay, so first thing is which are at level earlier should be coming before the numbers which are at later level, and if they are at the same level it should be in the sorted order, right? So let's see example here. So what are the traversals that we know? We know in order traversal, pre-order, post-order, and level order traversal. Using these traversal, we can basically do the we can give the vertical order traversal. Okay, so as discussed earlier, this is level 0, -1, -2, 1, and 2. Okay, so how can we possibly print it? So to do this, we can use any of the traversals. Let's say we are using pre-order traversal. So what we do is we have to somehow maintain two things. One is the vertical distance of the nodes, which is vertical distance. So the root has the distance 0 and the left child has a distance -1, the left child of the left child has a distance -2, and so on. And also we have to maintain the levels of each node. So these are different levels, okay, which we have to maintain. So this is level 0, this is level 1 2 3 4 and so on, right? These two we have to maintain. So how do we use these traversals to for our job? Let's see the code for this. So as mentioned earlier, we have to maintain some vertical distance as well as levels, and in the same level the numbers should be in sorted order. Okay, as mentioned earlier. So we are taking let's say we have to use pre-order to do this. So how can we do this? So what are the variables that we need to keep? So for storing the keys at various levels, so at a distance, let's say for distance -1, for distance -2, for distance 0 1 2, we can maintain the keys which are at this distance. This becomes the key and the values become the node at this distance. Okay, so the root will be at the distance 0, whatever the value is. Let's say the value is 9. Okay, so the left child, let's say, is 6, so it will go to the distance -1. Let's say the right child is 5, so this will go to the distance +1. Okay, and in this, since we also have to keep the print the nodes which are nodes which are at level above should be printed first. So for that we maintain a pair of the level. So this is level, let's say, uh, level 1. Okay, and the value is 6. So for root node it is level 0 and value 5. So this is the tree that I'm talking about. Okay, and this is also at level 1 and key 5. Okay, so the values are basically the level which the node is at and the actual value. Okay, so we maintain an hash map of vertical distance as the key and value as level and node values, and also that is also a set. So basically, since vertical level any number of nodes can be at vertical distance, so this will be a set. Okay, with some values. Okay, right. So let's see the pre-order traversal, considering an example here. Let me erase this. Okay, so let's consider this example where we have two, let's say, then let's say here it is 3, here it is 7, and let's say here it is 4. Okay, so let's consider this example. So how would pre-order basically traverse this? So when we are doing pre-order, so this is vertical distance 0, -1, -2, 0, 1, +1, and +2, right? So when we are doing pre-order traversal, in the hash map we will insert this level and root value into the set. Okay, so so we are starting from 0, we insert 9 is at level 0. Okay, 0 comma 9, then at -1 we will insert, since this is pre-order we traverse like this, so we will insert at level 1 comma 6. So this is level 1, this is level 2, this is level 3. Okay, so then we insert minus at vertical distance -2, we are inserting level 2 comma node value 2. Okay, and then we are inserting at -1, since after this node then pre-order it's this node, so which is level 3 comma 4, right? And then after this 5, so which is at level 1, 1 comma 5, then again level 0 we insert uh, vertical distance 0, this is level 2 and 3. Okay, and then 7, which is at vertical distance 2 and level 2, right? this is basically what we have printed. Okay, so this will be the answer that we should get. So this will have since we are using a set here, the set data structure stores the elements of the set in sorted order. So the pairs will be in sorted order. Okay, sorted by first the level and then by the keys, right? So here since level is lesser, so this will come first. Okay. And while doing this pre-order traversal, we will also store the minimum vertical distance and maximum vertical distance. So these two are used to basically uh, run the for loop for the distance and give a result in a vector. Okay, so what's happening here from vertical distance of, so the minimum vertical distance is -1, sorry, -2, and maximum vertical distance is +2 in this example. So the loop runs from -2 to +2. We have to basically return a vector of vectors, right? So these are all vectors. We have to return a vector of vectors. So for that, we iterate through the set for each key. For each vertical distance, we iterate through the elements in the set, and we just push back into the vector. Since the set is already sorted, we do not have to sort this. If we had kept a vector here, we need to have to sort this, right? So this is not required. So we simply push back the elements, the values. Okay, values is data dot second, and then we store in a result vector, and finally return the result, right? So what is the time complexity for this problem? The time complexity is basically the time required for pre-order here, which is O of n, and this loop, right? This loop is basically for all the vertical distances. We are basically traversing all the elements, right? This map will basically contain elements at a particular vertical distance. So overall this is also order of n. So order of n plus order of n is basically order of n, right? So what is the space complexity? Space complexity is also order of n, right? So we are storing all the vertical distances, all the keys, right, and extra level information. This is also order of n. Okay, order of n, right? So is there another way to do this? Yes, there is another way. We can also use level order traversal to do this, or we can also use the other in order traversals. Just these conditions will come here, right? Nothing else changes. Let's see how to do this in using a level order traversal. Okay, so let's go to the level order traversal. So the map remains the same here, since we have to maintain this level and vertical distance information. Okay, instead of pre-order, what we do is basically VFS, which is basically the level order traversal. So we first have the root node, we pass the root node. So if there is root, we insert here the queue has basically these three things. So the vertical distance, the level, and the node pointer. Okay, so we insert, since root is at vertical distance 0, the level is 0, we insert the root. Okay, and while the queue is not empty, this is basic BFS traversal. Okay, we pop the front node, right, get the front node, pop it up, we put the nodes information of the vertical order traversal in the map. So for the vertical distance of the node, we insert the level and the nodes value information, and then If there is left node, we calculate the minimum vertical distance minimum. If we have found a lesser number, we update the vertical distance minimum, and then we push the left pointer's element to the queue. Okay, so this is the left node, left pointer of left child. Okay, we are talking about this. And if there is right child, if we have found a vertical distance which is larger than the current maximum, we update the vertical distance and push the uh, vertical distance plus 1, current vertical distance plus 1, node's vertical distance, like here is 0, then this will be 1 and this will be -1. So this is its current value, this node's current vertical distance, -1 in this case and plus 1 in this case. So the level will be plus 1 and plus 1, 0. This is 0, so this is level 1. So plus 1 in both the cases. Okay, and we push it to the queue. Again, this loop continues. We pop the next element from the queue and enter the information of the vertical distance in the map, and then we keep doing this until the queue is empty. Okay. After doing this, the rest of the loop is same as the way we did for pre-order traversal. Okay, we just scan through the unordered map, that is the hash map, using the vertical order traversal, right, vertical distance, and we keep pushing to the result vector, and we finally return the result. So what is the time complexity here? Time complexity is basically the time taken for BFS, which is order of n, right, and the time taken for this is also order of n, so which is overall order. Time complexity is worst case order of n. What is the space complexity? Space complexity is basically the unordered map that we are maintaining and the queue that we are maintaining, right? This is also basically order of n. Okay, so that's it for this video. Hope you enjoyed watching the video. If you do like my work, please like, share and subscribe to my YouTube channel and hit that bell icon to be notified whenever I upload a new video. Okay, thank you so much.